Hi, everyone. I'm really excited to be speaking tonight to the Inspire Africa team. They have this amazing solution in terms of how to get children to really understand fourth industrial revolution tools. As you all know, I love playing with technology, and for me, things like drones and VR are just the best. And so exposing those to our children for me is very important. Oh, and my voice decided to go all crackly. So showing you those things and how you can implement them related to the curriculum is really important. Alongside that, they tie in the 21st century skills, which for me is something we really need to be teaching our children. So to start off the show, have a look at this intro.
Hi, I'm part of Inspire Africa's Learning Experience team. I'm here to share a brief overview of our Inspire STEAM programs for your school. Our programs are educational packages that utilizes 4 IR technologies that enhance learning in the classroom. We empower the educator through SACE accredited training to utilize 4 IR technologies and a well-crafted curriculum to ensure that they are fully equipped to do what they do best, teach. Our curricula are made by teachers, for teachers, and our packages incorporates robotics, coding, drones, 3D printing, and other 4IR technologies to ensure that your school has the tools it needs to foster 21st century skills within the classroom. These skills we further reinforce with our CAPS-aligned curricula that incorporates project-based learning with an emphasis on real-world connections. As the future is rapidly changing, we must equip our children with the necessary skills for the jobs that do not currently exist. It is our responsibility to ensure that we inspire the leaders of tomorrow to make an impact on the world to come.
By helping our learners develop 21st century skills through STEAM education, we are setting them up for exciting and enriching futures as we progress into the 4th industrial revolution.
So sharing these types of skills with our children, I think, is really, really important. Let me bring on the team. So hi, Simon. Thanks for being here this evening. I really appreciate it. The other 2 members of the team are Greta and Albert. It's really great to have you all here. So Simon, tell us, where did this project start? How did you even think of starting something like this?
So thank you very much for having us. If I could just start, and yeah, we really appreciate the opportunity and the audience. My journey really with this all started back in 2016. I was not somebody who'd been in the technology industry, and I hadn't been in education either. I was working for a commercial drone business, and one of the tasks that I was responsible for was introducing the non-commercial, the recreation and education side of drones to children as young as 5 years old.
Oh, wow.
Children young as 5 years old, how to fly drones, build drones, code with drones. And then towards the end of 2017 and early 2018, there was an announcement by Angie Masejo and Cyril Ramaphosa that coding and robotics was going to be introduced to schools. We know that took a little bit longer than was expected for various reasons, but it was then that I saw there lies the opportunity for us to actually take drones, coding, building drones, flying drones, racing drones, etc., not as an extramural, but bringing it into the curriculum. And so I went to the shareholders of the business at the time and I said, here lies a huge opportunity and a real need in schools to train teachers non-techie teachers how to integrate these technologies into the core curriculum. And they decided that they wanted to focus on the commercial drone industry, which was all fair and well. And so I started Inspire Africa at the end of 2018. And that's really how it all began. So before I jump into telling a little bit more about us and then handing over to my colleagues Greta and Albert, if I can just introduce them. So Greta is an ex-teacher. She taught for 11 years. So she drives our content development, our curriculum development, our CAPS aligned curriculum, our lesson plans, etc. And she's going to give you some real insight into that. Albert, who is the techie amongst us all, he is head of our operations and training and product development. So between the three of us, we really drive the business with the rest of our team. And yeah, this is just a little insight into into what we've been up to for the last 4.5 years. So if you don't mind, Karen, just giving us the slide access, there we go. So yeah, I've talked about the team. Although Greta and I share the same surname, we are no relation. She obviously married a good chap, just by citizen or wife. So what do we do? Before I jump into that, really what I saw before having started Inspire Africa, what I saw was this fear of technology and working in a commercial drone business. What I saw was these engineers who were talking above my head and let's say the non-techies heads. When they started assisting me with the training programs that we did for amateurs, for children, for the non-techies, they were talking at a level that the children and the non-techie adults could understand. And that's when I realized actually there's a real fear in schools for the majority of teachers who are not teaching the T in STEAM, being the IT teachers, the coding teachers, the EGD, or the technology teachers. So they were au fait and comfortable with introducing these technologies, but the majority of teachers were not. So we started this business really focused on the non-techie, and that is a non-techie student and it's the non-techie teacher. And in a nutshell, what we do is we train teachers and students how to integrate 4IR technologies into the curriculum. So when we talk about our footprint, this is what we've done in the last 4 years. We are very proud to say in all 9 of our provinces. We are also in Botswana schools and Namibian schools. A really nice mix of junior schools, high schools, all boys, all girls, and co-ed schools, ranging from the quintile 2 through to quintile 5. Top left is really our focus though, because by us training teachers, we can then reach so many more students. By us reaching and training the non-techie students, we don't have the bottleneck where the technology department is responsible for delivering the integration of technology into the core curriculum. So taking a back step to what is the 4th Industrial Revolution, what are 4IR technologies? We are already hearing the 5th Industrial Revolution being talked about, but the reality is we are well into the 4th Industrial Revolution. And this is really the integration of technologies. On the right-hand side, you can see, and these are some of the technologies that we are training our teachers, which include 3D printing, artificial intelligence, Internet of Things, drones, just to name a few, robotics, of course. All of these are intertwined and connected through coding, computer programming. So by us being able to bring these into the class, by using the technology as really the carrot to be able to get our students to be learning computer programming, coding, is one of sort of the things that we do. Because how do you expect parents, teachers, leaders in schools, never mind students, to keep up with what technology is relevant, what technology they should be learning. And if an example I like to use is 6 years ago, PricewaterhouseCoopers in their annual drone report said, in the next 5 to 7 years, there'll be over 100,000 different types of jobs in the drone industry alone. And you could say the same for cloud computing, robotics, Internet of Things, for example. So by us assisting the teachers in demystifying these technologies, what are the career opportunities for those grade 8 and 9s who are having to make their subject matter choices for grades 10 to 12? That is part of our job. Demystifying, making it fun, making it relevant, and delivering it in a format that teachers find easy to follow, easy to understand, and most importantly, easy to learn. How do you expect to teach children whose jobs have never been created? Well, that's one of the things that we do. In South Africa, it's actually over 70%, because I see this on a monthly basis. The number of new jobs, new careers that are in the engineering, the computer science, career space, the new jobs. So that is why it is important to adapt our teaching and exposure to the students. The way that we do it is through teaching STEAM education, because STEAM, it stimulates creativity, it enhances the 7 C's, which Greta is going to tell you a little bit more about. Because in today's age, our students, our youth, it's not about where do you find the information or what is true. It's about the problem solving around that information. It's about disseminating the fake from the real. It's about collaboration. It's about teamwork. That really is what we need to be preparing our students with and for. The way that we do it, as I said earlier, we don't simply focus on the technology teachers, because that in many schools can create a bottleneck. So Albert and his team, they focus on teaching across the entire STEAM spectrum. And under the sciences, that is not just physical science, it's biology, it's life science, it's geography teachers. Of course, it is the technology teachers, because they are the most au fait, but also they can assist the rest of the teaching body in terms of allaying fears of all of these 4IR technologies that we teach. But it's also about the creative side. So it's art, it's graphic design teachers, it's linguistics teachers as well. I mean, we've got many schools where we've taught teachers who are teaching English, Afrikaans, isiXhosa, isiZulu, French, German. Why? Because coding is a language. And then most importantly, maths teachers as well. And the reason why maths is important is because there's many abstract concepts in maths. And if you could, for example, be using a drone to teach the polygon equation, where maybe your A stream math students are not going to have a problem learning an abstract concept, but those that are a little bit more challenged could be using a drone or a 3D printer or a robot or a sensor actually to teach a challenging concept. So the STEAM teachers is who we focus on. And very, very importantly, I have mentioned this a few times, our students and our teachers do not have to have a computer science degree or a remote pilot license to be able to fly a drone. The majority of the teachers that we train have never, ever designed on Tinkercad. They've never even used block coding or Python programming. So it is about training non-techies to be comfortable, confident, to be able to integrate great technologies. Because if you're training the STEAM teachers and they are then teaching their children, well, there's a better chance and a higher proportion of students that are going to become au fait with technology.
That is so true. That is so true. And your whole point around the professional development and the teacher, for every teacher you train, that person will teach that way for the rest of their teaching career, rather than a child. Yes, the child benefits, but if we really want to change education, it's training the teachers. And I agree with you so from that point of view.
And Karen, you know, it's not just young teachers. The oldest teacher that we've taught over the last few years was a 70-year-old teacher. who is teaching for one of the Curo schools in Bloemfontein. So it's not simply the young teachers who may be the millennials or Generation Z teachers. It's actually any teacher, because why shouldn't you develop new skills later on in one's teaching career? The way that we do this is really our 4 pillars that we have. So that is for this constantly growing curriculum, which Greta and her team is responsible for. And it all sits on our learner management system, which is called the Inspire Campus. So that's our 2nd pillar. The 3rd pillar is the continuous professional development of our teachers. It's not simply after the initial training. So through our account management team, they are visiting our schools and our teachers. They're checking in with them on a regular basis. It's having regular webinars. So it's the continuous training development where the teachers are getting their SACE accredited points as well. And then lastly, very importantly, a hardware component to everything we teach. Not simply teaching one how to code on a screen or on a device, but actually getting a drone or a robot to actually follow an action, a mission, according to the code that's been written. Designing on Tinkercad or Fusion 360, and then printing it on your school's 3D printer. And as you know, you can print any object you want in using a 3D printer. It all depends on the bed size, which Albert will talk a little bit further. So we have schools like Pretoria Boys, like Uffies, that has over 300 students per grade. And then we've got home schools that have less than 20 students. So we then assist with the hardware needs according to their budget, according to their number of students and requirements. Very lastly, our process is, when we find this very important, Albert and his team of instructors and trainers have been all over Southern Africa. Most recently, he was in Botswana. He's currently in Gauteng. And the reason being is to ensure that the teachers really understand we need to build a relationship with them, 1. And 2, we need to see the environment in which they're teaching. So Albert and his team goes to the school, they onboard the teachers onto the Inspire campus, and they take them through the entire curriculum. They teach them how to set up their 3D printers, how to fly a drone, etc., etc. Those teachers then go on to teach their colleagues, and probably one of the best examples was Rustenburg Girls High School, where at the beginning of 2021, we trained 6 teachers on our 3D printing program. They went on to go and teach 57 other teachers, so across every department, how to integrate 3D printing across all of the subjects. They obviously teach the students. We provide you with the hardware, and as I said, then we manage the relationship through our account management team. So that really, in a nutshell, is what we've been up to for the last 4 and a bit years. Relatively busy, and there's still a lot more to do. But I'm going to hand over to Greta, who's going to give you an overview and some insights into the curriculum.
So Greta, we're looking forward to your point of view and telling us what you've been up to and how you implement all of this. I'm sharing your screen.
Karen, thank you very much. Right, so thank you for the opportunity as well to showcase and share Inspire Africa's approach to STEAM education. Now, STEAM education really, I've seen it being applied in schools in a variety of different ways. That's in extracurricular activity or clubs after school, as well as in the core subjects within the school, and then as a dedicated subject, commonly together with coding and robotics, or innovate, with STEAM as well. Our approach at Inspire Africa really is to promote real-world relevance within our STEAM curriculum. STEAM really is, it's an interdisciplinary approach to learning that integrates sciences. So like Simon mentioned, it's sciences such as natural sciences, social sciences, life sciences, as well as physical sciences, technology, engineering, arts, which includes your languages, your life orientation, your life skills, etc., as well as mathematics. STEAM education really, it's developed there to develop essential skills, essential 21st century skills within our learners. That really is promoting your 7 C's, which I'll explain a little bit later. And it's done through hands-on inquiry-based learning projects, such as project-based learning, where the children really engage in a real-world scenario, a challenge, or a problem. This approach really does encourage the students to think outside the box, to approach problems with from rather multiple different perspectives, helping them to develop a more well-rounded understanding of the world around them. In a sense, it really is important for them to understand what they're learning in their textbooks is relevant to the real world, and what's happening and what's going on outside of the school grounds, and for them to make that connection. This takes me to the 21st century skills, which really is a set of competencies. The 7 C's in education is not a new term for most of us in education. However, the importance of these sets of skills is not always achieved and accomplished in our set standard core curriculum, whereby when you're introducing STEAM and technology within your subjects, as well as a project-based learning focus or problem-based learning focus, you are starting to achieve in developing some of these skills for your learners. Collaboration, creative thinking, critical thinking, among communication, with communication not just being able to communicate to your partner or the group, but to provide meaningful feedback on what you've learned, to share your solution to the problem that you've just solved. And this is to a wider audience, whether or not this audience is your group of peers in your class, or whether it is to your community group and through social media platforms or a variety of other media technologies, such as social media or through videos, etc. Citizenship really does play an important part here, where we promote, global and cultural awareness of what's going on around us, developing character within our learners, promoting, self-direction and adaptability, how they are able to manage a problem, and if the solution doesn't work, how are they going to take the challenge on again and continue to problem solve until they find the solution. And this character is really important to develop in order for the learners to take responsibility as well for their own learning, to gain agency of their learning, and then to build confidence within our learners. And then lastly, computational thinking, which really is a problem-solving approach by taking big, complex ideas, driving ideas, or central ideas, or big questions, and then splitting them into smaller, more manageable parts, so that the learners are actually using logic and concepts and algorithms to try and formulate a step-by-step instruction for themselves on how they're going to achieve the solution or the execution of a mission or challenge. Now, with the 7 C's, we really also want, with our curriculum, pay a lot of attention as well to innovation, which is creating, your authentic ideas and using design and implementing the engineering design process, and then creating an entrepreneurial mindset for our learners as well. Inquiry-based learning really is, it's student-led. It is an approach that emphasizes student-centered learning. Project-based learning and problem-based learning really do seem to be thrown around loosely sometimes, especially because they're both a PBL. There is so much content and resources out there for us to learn more about exactly the nitty-gritties of project-based learning and problem-based learning, but essentially they both revolve around real-world scenarios, real-world challenges, or real-world problems, with project-based learning being more cross-curricular and learners actually executing a mission or producing a product or creating something, and problem-based learning being more about solving a problem and using investigation, analysis, and proposal of solutions to solve something. The problem-based learning is not necessarily to execute the solution, whereas your project-based learning usually is to execute something. Why focusing on real-world relevance? Well, this is a key question, and what is so important is that we are wanting the learners to understand what they're learning in that textbook. And I, as an educator, had all the time the students saying to me, but when am I ever going to use this? Why do I need to know this. And it really is for them to understand the real world relevance of what they are studying in their textbook, how it makes sense in the real world, and how it connects between the different STEAM subjects. So from better engagement, if the learner is actually experiencing a project and getting hands-on, you're going to have better engagement, even from your more reluctant learners. It improves problem-solving skills so that they can apply what they're learning to these solutions. Career readiness encourages civic engagement, which really is important for learners to understand what is socially and economically going on around them in their community, and how they can assist in creating a solution or building something or innovating something for their community or on a global scale. And then, of course, greater retention. If you are hands-on physically doing something, you're going to remember the content and recall the information better, especially if this is an assessment purpose where you get to assess the learner at a later stage. Now for our real drone mission. At Inspire Africa, we have got a variety of IRLs called Inspire in Real Life, which is our take on inquiry-based learning. And this is just an example that I'm going to show you with regards to drone usage in volcanic research, volcano research expeditions, etc. Now, because of the nature of volcanoes, humans cannot get close enough to access a lot of the information. So drones and robots are typically used nowadays to gain insight into these volcanoes, to do that additional research. In terms of drones, they're able to do visual inspections by getting detailed images of the volcanoes, using thermal imaging to detect radiation, to measure the gases. Carbon dioxide and sulfur dioxide are the two gases that are emitted by volcanoes, and the higher those readings, the more imminent an eruption may be, as well as LiDAR scanning, which is technology to create high-definition maps of volcano surfaces. The reason I'm explaining this is that our missions actually focus on real-world drone application. So our mission that I'm going to explain today is called Eruptive Technology. It's a little play on disruptive technology with regards to volcanoes. And with all of our IRLs, we formulate a driving idea for the learner. In this case, it's collecting data through technology to determine volcanic activity. But this project really is key focus in all of the different STEAM subjects. In this project itself, we've chosen the grade 7 social sciences term 2, whereby they are studying volcanoes in social sciences. They're studying the anatomy of them, the prevalence of them, the gases that they emit. And typically, you then have the learner go and paper mache a volcano and create a little experiment, and that is your project. But in our inquiry-based learning, we are taking it to the next level, and we are extending the project through the different STEAM subjects. So in sciences, they're learning about the periodic table of elements, whereby they can now identify the compounds and elements of different gases emitted by the volcano. There's also a little science experiment that they can do. We love the bicarbonate vinegar experiment. But before they do that experiment in engineering, they go and they 3D model a volcano, using their design skills to look at the contours of a volcano, add a little bit of creativity to it, and actually create and 3D model and print a volcano to do this experiment. Now, from a drone perspective and how we would use this real-life drone application in a classroom simulation is that the learners will then either fly manually or they will code their drone to fly over their little science experiment, which is a little erupting volcano, and using one of our products called the Icesense, which has got a sensor to read carbon dioxide levels. It then flies over the experiment and is able to take a reading of the amount of carbon dioxide that is emitted by the science experiment. Now, you can do one volcano, or we would love a group collaboration of a variety of different volcanoes so that learners can compare results and also see which was the most powerful volcano. And then in a maths activity, do a data analysis by drawing graphs and being able to determine, okay, out of all the different volcanoes, which one do we need to send out an alert for? Which is the most active? Which volcano is possibly dormant? Maybe they missed the volcano or there was no carbon emissions emitted. And they really are able to read this and see this is a real life drone application. They're able to simulate it in a classroom environment. And then finally, to report on their findings. through art. They can do this in languages where they present their findings in an oral, or they can become more creative by dramatizing a news bulletin or using graphics to create an animation, for example, and really bring the project together. So in a sense, this entire project could stem over a term. It could be individually run throughout the different subjects, or it can be used as an afternoon activity whereby the learners are actually applying what they're learning in class to a real-life simulated mission. So that is what one of our missions. We've got from relocating rhinos to flying perimeters around an apple farm in Elgin to inspect it for insects, for example, coding hexagons and filming a bee awareness mission. So many different missions that really stem across all the different STEAM subjects. So in terms of our curriculum as a whole, we really do focus on our inquiry-based learning, but we foster the 21st century STEAM skills throughout our entire curriculum. So from our IRLs to our I-Thinks, whereby we also provide the teachers with subject-specific lessons throughout your sciences, technology, engineering, arts, and maths, and provide them lesson by lesson and instructions on using technology, including digital technology, other forms of technology, and 21st century skills to implement into these lessons so that they really can be shouting from the rooftop that we are teaching 21st century skills from foundation phase as well as FET phase. From foundation phase through to grade 9, we also offer a coding and robotics curriculum, whereby what we've taken from the Department of Education's 4 strands and really extended it using our different technologies throughout every term, throughout every year, from grade R through to grade 9 on our LMS, whereby the teachers gain access to lesson plans, worksheets for the learners, and guided instruction, so that a teacher who has no idea about CAD is able to walk into the classroom confidently and be able to facilitate the learning process for their learners learning about CAD. And that's my presentation for you today.
That's really, really great in terms of the range of things and how you present it. So now we're going to look at some real things. So Albert, we're looking forward to this. Do you want to share with us?
Oh, thank you, Karen. Let me kick off on my side. So in terms of technologies, as Simon has mentioned, we do various kinds of technologies at Inspire Africa that we bring into the schools. First one that we're most well known for is probably our drones, because that was our first kit on the block. And a lot of people asked us, why use drones for coding and robotics? I think, as you can see on the screen on the presentation side of things there.
I haven't put your presentation up. Wait, Albert. I moved you. I thought you were going to show us your drone first.
Not yet, no.
Sorry.
No. Sorry, no worries. So essentially the reason why we use a drone, as you can see there, obviously there's a big component in terms of real world significance. But typically if you look at coding and robotics, you want to ensure that students learn it as a whole. So a normal ground robot that's typically used in many schools, we call them ground robots because they just sit on the ground. They can only move in 2 dimensions, meaning backwards, forwards, left and right. They can't move up and down. So the reason why we use drones is because you got that 3rd dimension. And as we all know, and it's been well documented, that as soon as students develop that 3D perspective, typically together with that comes an increased understanding of mathematics, science capabilities, and so forth. So by using a drone for your coding and robotics, you automatically get that added benefit in your mathematics classes and so forth. Now, the specific drone that we use is the Tele drone, as you can see on the screen there. It's a little drone. The reason why we use specifically the Tele is because you can program it either by making use of simple blocks, but you can also use JavaScript, Python, Node-RED. There are multiple options or coding languages that can be used to code this drone. So it's super versatile. Together with that, I'm just quickly going to share my screen over here. We offer a simulator option for a lot of the, well, for all our schools. And there are various environments, and these environments are being developed on basically on a 6-monthly basis. You'll find that there are new environments popping up. We have a minimal environment, which is really like a pink world. That would be for your schools that use laptops or devices that are not don't have big resources. But then you can also look at the city environment. There's a Mars environment, Himalayas. The builder environment is currently in beta phase, so it's still being tested, but it is available to all our clients. And that's very similar to Minecraft, where students can go and basically build their own world and then fly their drone in that world. An example of, let's say, the Mars environment, you'll see on your left-hand side your basic coding blocks, similar to what you would find in Scratch. In this case, it's just specifically applied to the drone scenario. And then on your right-hand side, you will see the actual environment with a little drone sitting all the way down there. And students can then basically build their code in here. At the same time, they can also test their code. So they can physically run their code and see if it performs the required task. Now, of course, there's nothing like doing things like this in real life. So with me, I've got a little drone here, one of our telos. So this telo comes with a standard battery. It comes with additional chargers. You'll see there are propeller guards around it, and the propellers itself are fairly flexible. So it's not like you that anyone can get hurt by this drone. The worst that can happen literally is a drone flying into someone's hair. That takes quite a while to untangle. But in terms of safety, the moment it hits something, automatically it turns off all the propellers. So I'm just going to quickly turn this on. And by making use of my phone, there are various ways to control this drone. On the one side, I can code it, as I've shown in the coding environment. But at the same time, we always start off by allowing students to play with the drone first. Main reason for that is get them excited about the drones, and then from there get them to that point where they realize, okay, we can actually get this drone to fly by itself without having to control it manually. So what I have over here is the Telo app. I don't know if you can see it that well on the screen.
Yeah, we can.
So I'll just put it down here next to me. And in terms of flying, it flies really easy. So you can see over here, whoops, that's too far.
That's very cool.
So you can literally see the drone hopefully in front of me.
So if schools have those, how difficult are they to maintain? How long does the charge last? How do you handle those kinds of things?
So when we look at the telos themselves on one battery, which are these little ones, it would typically fly for anything between 10 and 13 minutes, depending on what kind of coding mission you are flying, which is actually quite long. It might sound not that long, but if you take a typical lesson, would be around 30 to 45 minutes. And each school gets provided with a lot of additional batteries together with fast chargers.
Nice.
So essentially, as the battery comes out of the drone, it can go straight onto the charger. And with 4 batteries per drone, you can literally just cycle through and basically continue flying as long
How many drones do you recommend for a class size of, say, 30 children?
So what most of our schools do is they would put about 3 students on a drone. So they would do this as a group exercise. So typically at the beginning of the lesson, they will make use of the simulator to test their code. And then towards the end of the lesson, where they're fairly confident that their code is correct and working, then they will take out the drones and they will start testing and playing further in real life together with that.
Okay, that makes sense.
Then let me continue on the presentation side, because we do normal robots also, which is what you can see over there is the Inquirybot. Now the Inquirybot, the reasoning behind the Inquirybot is to develop a very cost-effective robot that's accessible price-wise to even our Quintile 1 schools, which typically can't afford 11,000 Rand robot, or they might afford one 11,000 Rand robot, but one robot for the whole classroom is not very effective.
No.
So that's why we decided to develop the Inquirybot. The Inquirybot runs on a microbit. Maybe I must quickly, I've got one here with me, so I can show you. So what you'll see on the screen here, this is the little Inquirybot. Now, when we did the design for the Inquirybot and the development, we worked closely with the Department of Education to ensure that all the needed sensors that is required by the Department of Education, plus a few extras from our side, obviously, are all built into the drone. So you'll find your typical sense and avoid sensors, your line following underneath. It's got a hole right through, so you can slide a pen right through. I don't have a pen with me now, but you can do robotic drawing. And you've got your programmable LEDs on top. So a little example of that. If I quickly turn this guy on. Let me press, I've put some basic code on there. Oops, let's go. Different colors. Now, this robot's also voice activated. So in this case, it's programmed that the lights will move 1 pixel, as we call it, by if it receives a loud noise. So we can basically see as I clap my fingers, we see the lights step on. Now that would be just one example. I'll show you the code in a moment. The robot itself is based around the microbit. A lot of our viewers will probably have recognized the standard microbit already. Again, why did we use the microbit? Microbit was specifically designed for the educational market. So there's a bunch of sensors built into it off the bat. So you don't just end up with a processor, but you end up with a processor that has temperature sensors in it, that has a compass built into it, accelerometers. All those things come standard already in here. And then together with the Inquirybot, it really forms a complete package. The Inquirybot itself, in terms of few further technical specs, it has a built-in battery underneath. This battery lasts anything between 4 to 6 hours on a full charge. So what most of our schools will do, they'll charge them up, and then that charge is usually enough to last the whole day through various classes that come through that specific lesson. It also, on our lesson side, if you can share my screen again, Karen.
Yep.
We make use of the MakeCode interface, which is developed by Microsoft. It's a standard interface. Again, start off with various blocks. Now, the advantage here is that the amount of blocks in this interface is really endless. There are multiple extensions that one can load for various activities. And at the same time, on the fly, you can flick between, let's say, Python and the blocks on the other hand, which really allows for students to move over from blocks to text-based coding a lot easier, because they don't all of a sudden just do text-based. They can, on the one hand, work on their blocks, and on the other hand, they can then move to Python. So typically what we would do is we would get them to design a set of code by making use of the normal blocks, and then we'll tell them, okay, but let's go and look at our standard code, and let's go and adapt our code to achieve a different outcome. For instance, we'll see pin 14 and 15 here that sits on a 0 and a 1. Now, this is like those two pins control the motors on the Inquirybot. So 0 and a 1 is like a positive and a negative of a battery connected to a motor. So if I switch those two values around, whoops, let me go that to a 0 and that to a 1. This will lead to the motor turning in the opposite direction. And at the same time, if we go back to our blocks, we will see that it's been updated now in my blocks also. So this is really a very nice interface to easily convert and adapt to the, as we call it, the text-based interface. Then if we continue further, in terms of 3D printing, that is kind of a natural flow that goes together with our with the various 4IR technologies. You might have seen in Grete's presentation that 3D printing and robotics are grouped together. Reason for that is there is a lot of attachments that you can print for the Inquirbot. You might have seen on the front of the Inquirbot, there's a programmable servo that gets expanded by making use of various 3D printed parts in the schools. And then you can create your own robotic arm with a robotic claw that is completely programmable also. In terms of the specific 3D printers that we provide the schools with, we are big fans of the FlashForge Adventurer 3s. Although schools that do have other 3D printers can still make use of our curriculum. Our curriculum is written in such a way that it's accessible and friendly to other printer brands also. But on our side, we only provide FlashForge Adventurer 3s and also Adventurer 4s for the schools that want something slightly bigger. It's a very simple printer, very easy to use.
You'll doesn't get stuck. You're not having to clean. Yeah.
No, so it really works very well in terms of calibration. Typically, you'll find in a school they'll calibrate the machine maybe once in 6 months. So that really makes the printing process fun. The last thing you want to be doing is struggling, fiddling with a printer non-stop because filament's stuck. Things are just not working. Because it's enclosed, it stays clean. It also controls the temperature inside the printer a lot better. So typically your print quality is better. You'll see it's got the touchscreen over here with a very easy interface in terms of getting things printed. But the main reason why I really love the FlashForge Adventurer series is because they are absolutely bulletproof. You can't break these things. I've been in many schools with Adventurers, and I found them in the arts classroom where the outside of the machine is literally half painted. It looks like that thing's been through war. But if you open it up, it's clean inside and it still prints 100%, no worries.
Yeah.
So yeah, we really love those FlashForge printers. Then the last thing that I would quickly like to tell you about is the Icesense. I've got one here with me, but I think you might be able to see better on the slide over there. But maybe to give you an idea of the size, if I hold it in my hand, I don't know if that works, but you can see it's fairly small. We have an adaptation for this also. Unfortunately, I don't have one with me now, but you can fit this literally onto your Tello drone or onto your Inquirybot to collect various sets of data. So,
sorry, just show us again. Hold it up again, Albert.
Okay, do that. There we go. So you can see it's very small. It's basically the size of a microbit. And you'll see it's got various ports at the back. Now, these ports are used to plug in sensors. The one sensor that I've got plugged in here now currently is a waterproof temperature sensor. So schools can use this in their science experiments, heating curves, cooling curves, grade 10, 11, 12 and up. And this basically collects that data for you. So you can literally set this up so that it takes, let's say, temperature reading once a minute or even every second if you want, or every half second. It's probably a little bit overdue, but it's possible. And that data then gets stored on the microbit. You can download it afterwards. You can pull it into Excel to do graphs. But at the same time, you can also display the graphs in real time via the MakeCode interface directly from your Icesense also. You will realize, again, microbit based. So if a school, for instance, already has Inquirybots with microbits, they can literally only just buy the, let's call it the chassis side of the Icesense with the various plug-in sensors. There are various sensor packs depending on what the school's needs are. So again, that is our latest development. Currently, we are still finalizing those developments, to be honest. The one that I have shown now is not packed in its clear casing yet, so it actually comes in a little clear casing, a little bit more protective. But yeah, that's from my side a quick overview of hardware.
And I think the solutions that you've shown and the way you present it just makes it so meaningful for teachers. I think you all know my background was teaching design and technology. I've taught it from grade R to grade 11. And for me, teaching, using the technology, showing the relevance, Greta, what you spoke about, relevance of tech is so important. And for me, it was always exciting saying to children, look at the tech, look how we're using the technology this is why you need to learn it. The maths you're doing over here means your bridge won't fall down over there. And so applying it just becomes so much more meaningful. So I think your solution is a fantastic solution to be sharing with schools. So I'm so excited that you're already in so many schools after such a short space of time.
If I can jump in there, Karen, just to add on to you were mentioning now the real application of these various technologies. Multiple schools are starting off hydroponic systems now at the school. And the Icesense forms part of many of the bases because it can, in real time, log temperature. It can control the temperature by turning on various elements and fans. It has, it can measure air moisture and all those kind of things. So, just another example of where schools really put these things into practice.
Exactly. I designed a technology center in the 90s, and we had a hydroponic center in there, and it was so difficult to get the sensors and things in that space. I mean, this just today, the way you have access to things so much more easily is just so much better. That's so exciting. For me, I think every school should have a vegetable garden. I think that honestly, and the way we can implement tech in that. Sorry, you were saying, Greta?
No, I absolutely, completely agree with you. It's also the yin and yang of technology as well as sustainable development with veggie gardens and using technology to, to really ensure that we are living sustainably, we are, living efficiently. Absolutely, definitely agreeing and hopping onto that idea of yours.
Yeah.
I
think we need to do those kinds of things in every school. So Simon, we sort of out of time, but I believe you want to end off with a few thoughts.
Yeah, absolutely. I mean, I do have some slides, some closing slides, but actually I don't think it's even relevant. It's really what I wanted to close with is, one, what's the benefit to students? Two, what's the benefit to the school, to the educational institution? And I think my very passionate team has put that across extremely succinctly. The benefits for both is it's about empowering students, preparing them for this 21st century, which jobs, careers, work life is changing at such a fast pace. How do you expect them, parents and educators, to keep on top? So that's really what we're doing is approaching it from a practice to understand. Packaging it all together and making it fun. Most importantly, it's about fun. It's about play, it's about bringing it into real world experiences. The classroom needs to be a laboratory of experimenting, of problem solving. And so that's really how I wanted to finish. And just one little thing, bringing in some sort of techie fun from an esports point of view. We launched last year our Inspired Drone League, our IDL.
Wow.
And that was really off the back of being asked by so many students, how can we race drones? How can we race first person view? Having come from a drone business and a drone racing business previously. And, whilst not everybody is competitive on the sports field or in the swimming pool or on the court, it doesn't mean that they're not competitive by nature. So our IDL is really harnessing that competitiveness for maybe some of those students that are a little bit more techie focused and bringing it into esports and gaming. But I just want to say thank you so much for the opportunity. I know we've run over time. As you can see, we could probably talk for a lot longer, but thank you for the opportunity and the platform.
No, I really think that this kind of solution is what our country needs. If we think of all the children that are falling off the bus and are not at schools, it's the kind of program that even those children could be exposed to and been putting them into jobs. And so if we think of the schools that you're in, if they have outreach programs, they could then be reaching children that have fallen off the bus. And I really think the more we do that, will really make our country succeed. So as we finish off, I would love you to share one thought, each of you, to say to people why you think they should really focus on either STEAM or 4R or 21st century learning. Give your closing thoughts. Greta, would you like to go?
Yes. For me, really, it's about bringing back the passion for learning. It's about bringing back the oomph. That is it. It's the oomph to know, how did this work? How can I make it better? And what can I improve on? And to inspire our children, not just to follow in a career field that is, designed for them to succeed, but to follow career fields that are really going to inspire them to make a difference. So for me, really, it is at the end of the day, when I'm creating content, I continuously say to myself, are the students going to be inspired by this? Is the educator going to be inspired by this? Because if the educator and the learner are both inspired, right, the fun starts, and the learning and the retention and the experiences had, that learning experience that you want for all of our children. So that's my final thought.
Thanks. Albert, and to you?
From my side, I think being part of the Inspire Africa team has brought me into contact with multiple teachers across Southern Africa and the rest of the world technically. And you get into so many schools where teachers are so scared of these new technologies. When they hear you flying drones in schools, they are, no, can't be done, can't do it. And when you get that 65-year-old teacher, with all due respect, that says, no, they can't, they'll never get it. And after 10 minutes, they're sitting there with their phone, they're flying the thing, they're taking selfies like they're 10 years old. I mean, that just makes it worth it, for sure. Because then all of a sudden, if they believe they can do it, then, well, the children's a lot more clever than us because they know all these new technologies. So then you sort it, yeah.
That's beautiful. Simon, and to you?
Yeah, I think what I have grown to realize over the last 6 years of being involved in this technology space is that South Africa is not alone out there. Our colleagues in the US, Europe, Australasia, first world countries, their school curriculum isn't necessarily any more progressive than ours. It takes a long time for a national school's curriculum to change, okay? So we cannot be pointing the fingers at the DBE or IB or whoever else. So that's the one thing. The other thing is when we get asked by schools is, we can't afford that. It's too expensive. Drones are way too expensive. And then when we show them, actually they're not. And I say to somebody, you know what? Even if you've got 10,000 Rand budget, it's mid-year, your budget's been written, it's been spent. Start small, but just start. Start maybe as an extramural initially. That's the most important thing. Just start with something. Don't say that you're waiting for a higher power. And we have seen from quintile 1 to quintile 5 schools, the most important thing that you can have is a champion or some champions, someone who is willing to put their hand up. And that is important. Don't force this upon your teachers. And we often get asked, we say, you know what? We don't have any teachers that can do this or that are interested or want to embrace it. Can you bring your instructors to come and teach the children? I say, you know what? With the greatest respect, let's talk in 6 months' time, because we are not then right for you. It is not about my team coming in and teaching your students. You, in time, will find a champion. And we've got schools that we were talking to 4.5 years ago that have now come on board because they found those champions. And many of those champions have been the IT managers, those who haven't necessarily been responsible for teaching students, but they are techie. And they are that bridge between the teachers who are fearful of technology and the technology which is coming, or the curriculum is coming. So, ending on a few things. but most importantly, champions, just start with something. We've got schools that have literally, bought one drone, one 3D printer, 1 or 2 robots, embrace the curriculum, and next year they will then be moving into, across further grades. So yeah, start somewhere. As I said, I'm a non-techie and I'm not a teacher, but I've brought together those 2 industry sectors. And if I can do it, if I can learn, if I can teach, well, then so can anybody else.
Well, I just want to say thank you for this wonderful presentation and for your sharing this evening. And I really look forward to seeing your products in lots more schools. Thanks, everyone, for watching. I'm going to end the broadcast. Have a good evening. Bye.
Thanks, Karen.